Today we are looking at day 2. So yesterday on day 1, we really took time to dig into some tables and analyze linear versus exponential growth from a table. And we also looked at the general form of a linear function compared to the general form of an exponential function. Today's notes are going to really be about understanding the general form of an exponential function as written here. So that's why it says recall the equation of an exponential function, and here it is. This is something that it would be very worthwhile to literally write like 10 times over and over until you just know. F of x equals a times b to the x minus h plus k. We need to have that memorized. We're first going to look at how h and k actually affect the graph. So let's get into some notes. If you have some highlighters, that would be good. From time to time, I will be highlighting pieces to help them stand out. Let's first answer, how does the h value affect the graph? So very carefully, I'm going to try to circle h, but I don't want to write over the negative sign. So if you can kind of circle it without covering up the negative, the minus sign. H is the horizontal shift. Left or right. And then here K is the vertical shift. And by vertical we mean up or down. Just going to take this. My little circle looks weird. If you can circle it nicely, do that. But I'm just going to draw an arrow up to it. Notice that x minus h is in the exponent position way up high. And look at the size difference between how small x minus h looks and k looks. So how you write it really matters. All of that piece, x minus h, is an exponent. The plus k is outside, a big number. Since the k value shifts the function up or down, it will be the location of what we're going to call the asymptote. And that's a very important vocab word, so you should highlight it. If not right there, right here. Maybe just underline it here. The equation will be y equals k. Little side note here. Recall that y equals a number is a horizontal line. So prior knowledge really does come into play. For example, right here. Let's really understand what an asymptote is. So by definition, an asymptote is an imaginary line that the graph approaches but never touches. An imaginary line that the graph approaches but never touches. And if we were to sketch an exponential function, I'm going to just draw one. There's an invisible force, so to speak, on this graph right here. And I'm putting it as a dotted line because it's invisible, it's imaginary. That dotted line would be the location of k, and its equation would be y equals k. That's the imaginary line that this graph will never cross. And again, it's dotted because it's invisible. The best way to really own these characteristics is to practice them. So let's jump right into our first example. Example 1. Given the function f of x equals 2 times 4 to the x plus 2 plus 8, identify the h and k values in order to describe the shifts and determine the equation of the asymptote. So first our job is to identify h and k. So I'm just going to slide this up so we can see this at the same time. I know mentally I'm thinking a times b to the x minus h plus k. So if it helps, above this, go ahead and write x minus h. I see x minus h, but then look, I see x plus 2. How is that possible? Well, to get a positive 2 means that a negative 2 was plugged in right there. Because originally it's x minus h, and I see a plus 2. So a negative 2 was plugged in to make that minus sign a positive. H being negative 2 means a shift left 2, because H is all about horizontal shift left or right. K is a positive 8. So K is 8. K is all about vertical shift. So this means a shift up 8. So before we move on past H and K, you might want to write yourself a little note. Negative built in x minus h. There's a built-in negative right there, if you weren't sure how I got that negative. Our asymptote comes directly from k. So if k equals 8, that means that y equals 8. Is the equation of my asymptote. And since I have some space, I'm going to put one more helpful note in case somebody is still not understanding how that's a positive 2, but h is negative. I could have written this x minus a negative 2. Minus minus turns into that plus, so h is definitely a negative 2. And then k plus 8, that's pretty straightforward. So on your own, notice it says your turn. Go ahead and try this next one all by yourself. Try the your turn, and then we'll see what we've got. We'll compare our answers. So to help myself out, I'm going to write x minus h right there. I know that's k. So x minus h, x minus 4. Nothing to worry about with the signs. It means a positive 4 was plugged in right there. So h is 4. And then whatever k is, if that's a positive 1, it means k is 1. If that was negative 1, k would be negative 1. We have the values. Now let's describe what it means. H is always a horizontal shift. Positive means to the right. So this is shift right 4. K is vertical. So that means shift up 1. Asymptote comes straight from k. So y equals 1, and we're all done. So that's how we work with A, H, and K, or excuse me, H and K. We haven't really talked about A yet. So if you want to make a big note, this was working with H and K. Now let's talk a little bit about A. To be able to sketch a graph, not only do you need to know the location of the asymptote, which comes from K, but also whether it is a growth or decay function. growth function. Let's highlight that. And now for some notes. For a growth function, we have a positive a value. So positive a value. And b is greater than 1. A sketch, we're going to be fitting a sketch down here as well. So kind of try to mentally divide the space. Don't come down here too much. Let's sketch a graph. From left to right, if it's growing, it's going up. And again, we still have that invisible asymptote. So let's sketch it in just so we don't forget it. So we see here, here's our asymptote. The graph is moving away from the asymptote. Graph moves away. From the asymptote. When I look at this from left to right. So left to right, it's going away. Also, larger the b value, steeper the graph. So a b value greater than 1 could be 2. Another one could be 100. If b is 100, it's going to definitely be steeper than if b was 2. That's what this means. We've talked growth. Now let's talk decay. Let's highlight the title. We still have a positive a value for decay. Positive a value. But now b is going to be between 0 and 1. It's going to be a fraction between 0 and 1. So let's actually write that. B is a fraction between 0 and 1. Let's draw a sketch. Let me put my asymptote in there first. So growth, the graph moved away. With decay, the graph moves toward. Graph moves toward. Put an S. Towards the asymptote. Left to right. So here it's away. With decay, it's towards. For our class, we will not be looking at cases where a is negative, because as you notice, for both growth and decay, these are positive a values. Up here, I'm just going to sketch what would happen if a is negative. You are not required, don't put this in your notes. I just want to show you what it looks like. If I had a negative a value, that's when the graphs are below the asymptote. So the only note I will write, I want you to write this over here, positive A value, graphs are above the asymptote. And if you notice the graphs we sketched, here for growth, it's above the asymptote. Here for decay, it's above the asymptote. Negative A value would be when it's below. This year, we are not looking at those cases. We're only going to be looking at positive A values. Example 2. Notice we are now going to hold ourselves a little more responsible for even more of the characteristics and knowing what to look for. So example 2 says, determine if the function is growth or decay, identify the asymptote, and sketch a graph. The best thing we could do to help ourselves out is at the top actually write the original function, but without numbers, just the variables. So it's y equals a times b to the x minus h. Notice how careful I am to make sure that this is up high, plus k. And now I have this in my mind, actually, well, not even just in my mind, as a reference at the top of my paper, and now I can use it. So when I mentally try to kind of overlap this with this, y equals a times b. So a is an invisible 1 that's in the front. We can't see it, but it's there. 1, a times b. b is 7/2. Seven halves is the same as 3.5. Let's pause right there. We've identified A, we've identified B. To know if this is growth or decay, we have to go back and look at what we just wrote. Growth, we should actually probably highlight this. Highlighting this would be a good idea. Growth is when B is greater than 1. Decay is when B is between 0 and 1. Growth, greater than 1. Decay, between 0 and 1. So when I go look at what I've got, B is 3.5. That's definitely greater than 1. So let's write a little note. This is growth. And in parentheses, write yourself a little note, because B is greater than 1. Nah, scratch that. Growth. And hey, look, there's a line that says Y. The reason why B is 3.5, and 3.5 is greater than 1. B is greater than 1, it's growth. In parentheses, also write, and we've got a positive A value. I know we're not going to look at negative A values, but if you ever take a math class where you deal with negative A values, I really hope we can keep in mind that the entire time we talk about characteristics, it's a positive A. I don't want us to lose that characteristic of knowing if it's positive or negative. So the focus will be, is B greater than 1 or between 0 and 1? In parentheses, let's just keep a running note that we do have positive A values. Asymptote. Well, asymptote comes from K. And you might be saying, well, wait, Ms. J, I don't see a line here that says K equals. That's okay. Off to the side, let's say what's H and what's K. Well, when I look to see where H should be up here. I don't see anything right there, so H is 0, which means no horizontal shift. K is very clearly -3. So that means a vertical shift, because K is all about vertical shift down 3. And now that I've identified K, I know my asymptote. The asymptote will be Y equals -3. with our sketches, we could technically create input-output tables and get exact points, but we're not going to do that. The only thing you're going to be accountable for is to correctly sketch the asymptote, first of all. So let's do that first. It's going to be a dotted line. Y equals -3. So 1, 2, 3, that's a dotted line through -3, horizontal line, special case, y equals a number is always a horizontal line. And please label that, y equals -3, asymptote. And because this is growth, I know that it's going to be moving away from the asymptote left to right. And we're done with our graph. So we're ignoring H and K, and for the graph, you're just going to use, you're ignoring the horizontal vertical shift piece. Just graph your asymptote, y equals -3, and sketch it. Is it going away or towards? And you're done. So I guess you could argue you're using K, because that gets you the asymptote. But my point is, I'm not expecting any values on this graph. Okay, moving on to B. F of x equals A times B. So right there, I know A is 2. A times B. B is 2/3. When in doubt, divide. So 2/3 in your calculators, go ahead and figure that out. 2/3 is 0.67. So when I go back and I look, B greater than 1 is growth, between 0 and 1 is decay. Well, 0.67 is definitely not bigger than 1, and it is between 0 and 1. So now we have our first decay example. The reason why, B equals 0.67, and that means that we have a value that's between 0 and 1, still keeping track of the fact that we have a positive A value. To know what our asymptote is, we need to identify H and K. Here, I see x plus 1, but that positive should be a red alert, like a stop sign, because I know that originally it was x minus H, which means a -1 was substituted in there to make that plus sign happen. H is all about horizontal shift. So this is a horizontal shift left 1. Here K is a positive 4, so K equals 4. K is all about vertical shift, so this is a vertical shift up 4. I know that K is 4, so I know that my asymptote happens at y equals 4. And again, to do our sketch, the only two pieces of information we're going to use to draw a rough sketch is our asymptote, first of all. So I go 1, 2, 3, 4 right there, and I'm going to draw a horizontal dotted line and write y equals 4 asymptote. This is decay. Decay means that left to right, I'm just going to remind you of the notes you just wrote down. The decay means graph moves towards the asymptote left to right. Towards the asymptote left to right. And we're done. Your turn on C and D. So right now, I'm going to ask that you press the space bar, pause the video, and completely do C. Once you press play again, all of C is going to be here for you to check your answer against mine. So seriously, press pause right now. Use what we did in A and B to help yourselves out with what to write, all of these words, model your work right around this, and then we're going to compare, okay? So I'm going to press pause, you're going to press pause, and go ahead and do your work, just for C. Here's my work for C. So go ahead and pause if you want to take a second to compare. I'm going to talk step by step through how I got my answer. So first, I mentally say to myself, y equals A times B. So A has to be an invisible 1 right here that I don't see. A times B. So B is 1/4. I know that 1/4 is 0.25. That tells me that this is decay because B equals 0.25, and 0.25 is definitely between 0 and 1. Then I say, well, what's H and what's K? And I was like, well, this is just X, so I don't see plus or minus a number. So H is 0, meaning no horizontal shift. In theory, you could say X minus 0. And then also right here, I don't see any plus or minus a number at all. So there's a plus 0 there as well. K equals 0, no vertical shift. That means my asymptote will be y equals 0. I draw my dotted line, my horizontal dotted line right on the y-axis at y equals 0. Decay means that left to right, this is moving towards the asymptote. And I'm done. Let's work on D. So once again, I'm going to ask that you pause the video right here, that you actually try D all the way through, and then we'll compare our answers and see where we're the same and where we might be a little different, and wrap up any questions you might have on this last practice of the notes. So you press pause, I press pause. When you're ready and you press play, all of the work will be here for D. So really do what I'm asking, press pause and give it a try. Here we go for D. How did we do? So let's talk it out. I mentally say to myself, y equals A times B, so A is 1/2, B is 3. Even though A is a fraction, it's positive. That's all we need to know to make sure that our graph is above the asymptote. So positive A, B is 3. That tells me it's growth because B is 3, and that's greater than 1. I then go and I work on what's H and what's K. Remember, in the parent function, so to speak, this is X minus H. So do not fall into the trap of saying, oh, H is -4. No, it's not. For H to be a -4, I would have had to see a plus sign right there. If I saw a +4, that means a -4 got plugged in. I don't see a plus sign. I hope you don't either. That says X minus 4, X minus H. So H is a +4 right there. That means horizontal shift right 4. And then K plus 1, so K is 1, K equals 1. That means a vertical shift up 1. That also tells me my asymptote is at y equals 1. So I draw my dashed horizontal line through y equals 1. And then it's growth. So that means left to right, the graph is moving away. Growth means away from the asymptote, left to right. That wraps up today's class notes. Tomorrow in class, we will work on day 2 homework. Nice job. See you tomorrow.